All right, awesome. Thank you all for joining this session. I think as the title suggests, we're going to focus on how Apache Iceberg is actually changing today's data landscape and how we're leveraging ISVs such as Starburst to help our customers address some of the challenges we've noticed on the field in terms of storing data, manipulating data, translating data, however you want to call it, right? I'm going to start from the very basics. I'm going to introduce to you guys why we are focusing on open table formats today. What is Apache Iceberg all about? We're going to give you a rundown of the overview. We're going to talk about the evolution. And eventually, we're going to show you a few reference architectures that Monica is going to do a hands-on lab and walk you through. And I just want to make sure that everyone's on the same page before we get to the actual hands-on experience, right? All right, we can move on, Monica. Let's go to the next one. Yeah, perfect. All right. So the important thing to understand today is, data is continued to be our differentiator, right? Whether you're building a simple application, traditional ML application or a Gen AI application, whatever you're building, data is still the key differentiator, right? And we've noticed that platforms have evolved over time as well. For example, when we built traditional data warehouses, right? The initial use case was, hey, we have extremely structured data. We're just going to do a few SQL queries, create a materialized view, and then we're going to visualize it in QuickSight, right? It was that straightforward. It was used for ad hoc analysis. It was used for business analysis. It was used by data scientists to figure out, hey, what the hell is my data all about, right? So that was initially one of the reasons why we built data warehouses. The other aspect was, you had a lot of applications which treated high velocity operational data. And so what if I want to look back in time, right? What if I wanted to store all the operational data in a data store and then look at the data or do some diagnosis on the heuristics? Then I would have to load in the data warehouse, and maybe I might run a query 1 or 2 times a month, whatnot, right? So that was the initial, need for data warehouses. Now, why did we grow into data lakes, right? Because eventually what happened was this very rigid structure of a data warehouse became expensive, right? Because customers would have petabytes of data. I remember 10 years ago, Monica, when we started our journey 10, 12 years ago, 500 MB was considered big. 1 GB was considered big. Today, we're talking about petabytes, terabytes, and even more, right? Or exabytes of data. So I think the evolution of data warehouses was like, you know what? We can't store all the data in our database. We can't store all the data in our data warehouse. We need to have a data lake, as we call it, right? We need to have data stored in an open format where you can actually access the data for not just one use case, but multiple use cases. And the other evolution was data did not confine itself to being only structured. Data continued to evolve. So you started having JSON files, you started having semi-structured and unstructured data. So there was a lot of complexities involved. I'm not saying data warehouses cannot solve those problems or cannot address those problems. They can, but there's a lot of manual effort involved by the user to actually structure the data, put it in a certain format, right? I remember the saying back in the day where I used to say, we had to bring the data to the machines, right? We had to convert the data. We had to do translation of the data, bring it to the machines and, feed the beast, so to say. But today we're saying we're going to bring the power of the machines and the compute to the data. So you can keep your data wherever it is today. It could be on-prem, it could be in whatever cloud, it could be in a data lake. We can keep the data where it is, and then we can run queries on it. And that's where the customers have got to. Next slide, please, Monica.
I still remember when I was a data engineer looking at wikis to try and get the format so that I could absolutely load something into the data warehouse. It was insane.
Night and day today, right? So today we're saying like, hey guys, keep the data as it is. No need to translate the data, no need to transform the data. So you can directly load it in your data lake, and then do your analysis, right? And so this is what happened, right? So what did we as industry experts, right, in the data engineering fraternity and, cloud providers like AWS, ourselves, and, Monica and Starburst team, we figured out this evolution. We had to have a common ground, right? Can we decouple compute from storage, right? Can we isolate both so that we can scale horizontally and vertically, right? So we started introducing that, right? And data warehouses started introducing their own mechanism, right? For example, Redshift introduced something known as Redshift Spectrum, right? Where you could actually query data in S3, right? So we evolved over time. And then on the other side of the fence, right, when data was in a data lake, we would also build ETL pipelines to load it back into the database, right? And so data would move between both the worlds. And then one of the common questions that would come up is, hey, how do you ensure data is proprietary, data stays secure, and there's absolute governance of data across your data sources? Great question. Number one question that all our customers have. And at AWS and Starburst, we believe security is P0, right? So we introduced a lot of services and protocols to ensure the data is absolutely secure, wherever it is, right? So we have a concept known as AWS Lake Formation. For those of you not familiar with it, Lake Formation extends beyond just your data lake, right? Into any service that connects with your data and ensures all the roles and IAM policies that you have in place with your original data set is propagated throughout the seamless effect. And then you can also manage the access control through Lake Formation, right? So for example, if you want to give read-only access, go to the console, select this user has only read-only access. It's that easy, right? I think customers want a solution in a one-stop shop. They want it easy. And it's not about the costs alone anymore, right? So that's where customers have been bought. Next slide, please, Monica.
I can't stop adding to you. We say all the time, it's price performance, right? It's price performance for your environment. That is such a big deal. It's about where can you get the most bang for your buck on with, the trade-offs that you require. That's we've done a lot of things with trying to, make Trino the most price performant engine for all of the Iceberg queries. And I don't know, just hearing you say that really, really rang the bell for me.
Absolutely, and it's you hit it spot on, because I think customers have realized that they can't confine themselves to using one tool, right? Like it's a multitude of tools, right? And it's a combination of service and solutions. So it's not a one-stop shop, right? But I think we're trying to simplify the architecture and the design, right? So what are some of the challenges of the data lake side, right? So we talked about some of the challenges of the data warehousing side. What are the challenges of the data lake side, right? Now, because of the fact that you have multiple data sources, you're going to pull in and federate data across all these data sources. Who is ensuring that there is data quality? As data engineers, and I'm a recovering data engineer, I could always say that. Monica knows as well, we've got the same background. Data quality is P0. Is this application behaving the way it is supposed to? Is this column supposed to have null records, right? This question constantly pops up in your head. We would have nightmares about it, right? Okay, first thing I wake up in the morning, to have my alarms set up, to have my job scheduled in the right way, right? And data quality is a problem that has existed for years. And I think over time, customers have realized that, clean data is what we need. If you tell, your LLM that the sky is, green, your LLM is going to say the sky is green, right? So at the end of the day, garbage in, garbage out, data quality has been utmost priority. And that has been one of the challenges with data existing in different sources, right? So there's no one source of truth. Second option that we've noticed that why customers have struggled is, when you perform very fast record level updates and deletes, there is a little bit of latency. There is a little bit of delay, right? And that does not help. For example, if there's a fraudulent credit card transaction happening somewhere in the world across Europe, and it's my credit card, I want my bank to act right away. I want my bank to cancel my card right away, right? Not 24 hours later, not 48 hours later. And that was one of the challenges with data lakes, because data lakes were initially built just for heuristics, batch data sets, and batch processing. That was not in the book or the manual that data lakes had to support real-time record updates and deletes. That was not why data lakes were built. The last but not the least is, how do you manage these tables, right? So let's say your application generates files at an hourly basis or on a basis of a minute? How do you keep track of that? How do you version your table metadata? It was a challenge because the data lakes were not built for that, right? And that's why we had databases managing that table format. And then the data lakes were just supposed to feed raw data in. And then from there, the customer had to figure out what they wanted to do. So data lakes were never built with these requirements. But as customers' requirements changed, we had to evolve with technology as well. Monica, what have you seen on your side?
I was just thinking back of the real timeness of like how data is coming in so much more. We're growing in that data quantity, but also that's a lot for the table management perspective, for the record levels. And we're gonna do a fraud example later. So that was absolutely perfect to reference. It's like you and I planned it or something, looked at the material, but that's kind of the examples that we see happening where things are getting faster, even for OLAP. Any
Yep.
sort of analytical data, that you're processing, you need that, not necessarily the same, you can't do that batch processing as much anymore. You really need to kind of accelerate that. And with that comes more files, which will
Yep.
increase your performance. And so you just need to kind of make sure you're on top of it. And then of course, data quality is a huge, huge problem in itself. That is a multi-prong approach. You have to be very holistic about approaching your data quality.
Absolutely. Spot on. And so as we get into the next slide, I think this is where, if you remember going back, in 2 slides, we had these circles, isolated, right? They were not together, but today both was have found common ground, right? So we've merged both of them, and merge and upsert. I like to use terms that we used in our data engineering world, but this is where we're at today, right? So if you notice, there is a lot of synergy between data lakes, databases. We have everything in between. We've optimized, databases to read semi-structured and unstructured data as well. And on the other side, data lakes, we've made it very easy to consume structured data as well, right? Because it wasn't originally built for that, but that's how we've optimized it. And then we've also gone to the level of optimization in terms of partitioning, right? We've introduced ways and numerous ways of how to format and partition your data. Because at the end of the day, one bad table design or one bad data set design could mess up your whole application, right? So you don't want that. And so that's why it's very important to consider all these factors when you design your data lake, right? And to address that, we introduced the open table format, right? And what is that? We'll talk about that in a bit, but we'll show you how that's done as well. Monica.
I think that's it. Let's roll to the next slide. That was said perfectly.
All right. Perfect. And I want to spend a little time on this, right? So here's where when we fathom the open data lakehouse, right? So we start at the bottom where you have to figure out storage, right? And storage has been inexpensive for years, so it really doesn't matter. You can store your open tables, your data sets in S3, right? Which is our standard de facto. I like to call S3 as the mother of all inventions at AWS. Don't quote me on that, but that's the way I believe, how we go about things, right? And the second aspect is, in the open file formats, right? So we have multiple formats as well, right? So there's Parquet, there's ORC, and there's Avro, and there's a ton of options, right? Now, what is the next layer in the evolution, right? So that's where we introduce open table formats like Iceberg, where it can support all those formats. You can store them. And then last but not the least is the compute layer. And that's where we give the customers the flexibility, right? So customers can pick and choose what they want to use and design the data lake, right? Now, Trino has existed for years, or as it was called, open source Presto, and Monica will dive deeper into that. But this has been the fundamental basis of our compute layer, right? And we've seen customers achieve tremendous success in terms of how they structure the data and even format the data in consuming the data in various levels. If you can go to the next slide, please. Yeah. And today there's a list of options, right? We're not saying one's better than the other. We're not saying, pick Apache Hudi over Iceberg or Delta Lake over Iceberg. It really boils down to your use case, right? Now, what we've noticed is if you want an open table format which involves highly operational data, right, and batch data, then you're better off using Apache Iceberg, right? Now, if you only have processing data lakes or data sets where you have petabytes of data, you just want to run processing and there's no real-time data involved, probably you're better off using Apache Hudi, right? And I'm not going to get into the details of all of them, but there are clear differences. There's not one over the other. It's why we use them and for which use case we address them for, right? And so that's where we're at today. Next slide, please. Now, the reason we built these open table formats is to ensure that they're all ACID compliant, right? You can manage your metadata. And as we've talked about, the fact that the schema itself continues to evolve, right? Schema evolves on a daily basis. It evolves every minute, right? So when you have data coming from IoT devices, it could be night and day between one file and the next file, right? How do you account to all of those? And that's what we're addressing with the open table format. And last but not the least, if you want to address time travel as well, that's something that open table formats support today as well, right? So we address all the issues that we've had in the traditional world, and we're ensuring that we carry that forward with the open table format support. Next one, please.
And we'll do time travel a little bit later in the lab. So we'll get to play around with it and get some examples.
Yes. And we're going to talk about a little bit about, I don't want to spend a lot of time on this, but, we have to understand, the history of Iceberg. It was originally developed by Netflix. And Netflix has a habit of developing a lot of open source stuff. And they still run on open source Cassandra, by the way. If you guys are familiar with Cassandra databases and data stacks that they're offering. But, Netflix runs on open source Cassandra, even till today, right? And we've seen the evolution of where it is today. And if you look at the AWS announcements that we've had, we announced official support at reInvent in 2022, where EMR and Athena, two of the services, actually support Apache Iceberg. You can move on, Monica.
Okay, let me give my one plug for Trino. Trino was, Iceberg was actually developed for Trino to be utilized at Netflix. So that is kind of the big thing here is like, it's really powerful to have that Trino and Iceberg combination. The two communities are pretty intertwined because of that. And it's been really fantastic because we've got to see a lot of growth on each. I think they started support for it in 2020 when it was still incubating. So it's really exciting to kind of see those two communities flourish. And we've got some really awesome Trino Summit talks coming up in the end of December. So stay tuned for those where we can talk more about, the combination of Trino and Iceberg, and I'm sure some of those will be on AWS.
All right, perfect. I think we can skip this slide, Monica. We can go to the next one. Yeah. All right. So why are we prioritizing innovations with Apache Iceberg, right? So these are some of our top customers and vendors that support and have built their production-ready applications on Apache Iceberg, right? We just talked about Netflix. And Adobe and Airbnb are some of our other big customers. And if you guys are interested to learn more in detail, we have public referenceable case studies on every one of these customers and their deployment methodology extensively listed out in our AWS official page, right? And as you can see, Starburst is one of our long-standing premier ISVs in our segment that has offered support, for Apache Iceberg. In fact, we work very closely together with the Trino team as well, the open source Trino team, to focus on feature development and ensure that we address every customer's challenge, right? So that's why, AWS and Starburst have been jointly innovating on this. And this is, I think, the future where we see it in terms of data management, right? Next one, please, Monica. And I think this is something maybe, Monica, I know you're smiling there. You want to take the slide away and focus on what
I'd love
Starburst
to. Yes. So wanted to kind of talk about, we talk about a lot of this, data lakehouse, open data lakehouse architecture. The thing I mentioned previously is that we have the Trino and Iceberg combination. So we like to refer to that as the Ice House here. And again, lots of our Ice Houses, I'd say most of our percentage are built on AWS. And really, we think about the Icehouse as like those 4 components, right? So combining that Trino and Iceberg combination, separating compute and storage, but then you also need that security, governance, and access control layer around it to make sure that you have all of the pieces in place for, like we talked about, making your performance better on your small files, for, making sure your compute cluster matches the right workload, all of these component pieces that might be something you have to manually create on your own or scale on your own. And instead, this is what we've put together is our Icehouse offering, which includes ingestion. So it's from the beginning of that near real time conversation that we had, and then building on that data management, specifically, compacting small files, doing all of the information that you may need to increase performance. We'll do some optimizations later in the lab. So this will be some of the things we'll lean on for the data management side. We also have, like I mentioned, that automatic capacity management. So looking at specifically those fully managed, optimized Trino clusters, what you can do to scale up and down your workloads. And then, of course, that governance component, because as Anthony mentioned, you can't operate in a silo anymore. You have to, we've talked about the components of data quality, which have always been an issue and still are plaguing us today. And, we've talked about all of these different components you have to kind of modularly build together. And so for the teams who are trying to get up and running with Trino as fast as possible, specifically Trino and Iceberg and Trino, Iceberg, and AWS, we want you to look at the Icehouse, and we'll talk about it more later. And this is just kind of a little slide about like some of the customers, what they're saying about this AWS Icehouse. And like Anthony mentioned, we have case studies available that we'll send out after this lab for you based off of what people are actually utilizing. But it's all the same principles we're talking about. We're talking about that open architecture. We're talking about that modularity. We're talking about that scale. We're talking about price and performance, things that people are now continuing to build up as they move into their next generation architecture. So we'll send these slides out, like I mentioned, but this is kind of the example of some of the people, what our data engineers are saying about moving from, their old monolithic architectures to more of their data lakehouse architecture. We've actually, the yellow case study, they were specifically modernizing from that data lakehouse to the data lake, or from that data warehouse to the data lakehouse. So it's interesting to see that transition that we talked about earlier. Anthony, I'll hand it back over if you want to talk about the benefits.
Awesome. Thank you, Monica. And I do recommend highly, taking a look at those case studies, because, you don't have to reinvent the wheel. Maybe some of those customer reference architectures could be used, and you can leverage, the same approach to solve your problems, right? And I think, some of the key benefits, and I'm going to go over the next 2 slides together, right? And I think this is what we try to achieve with the open table format, right? Is how do we ensure asset compliance, right? Just as we have in real tables in a database, how do we ensure that we have that in open table formats as well, which is what we introduced in Apache Iceberg. And the other aspect is when you talk about, the SQL layer, the way we query data is, it's remarkable how even SQL has evolved over time, right, Monica? Like, back in the day, it was like SQL was just needed to just do simple queries, join a few tables, and that's about it. But today, we can run advanced ML algorithms, ML studies, inferencing and training, batch processing. Everything can be done through SQL. That's how powerful SQL has evolved as well. So it's not just the data, it's not just the technology, it's not just the open table formats that have evolved, but even SQL has evolved, right? So there's a ton of features that SQL has advanced in Apache Iceberg. Some of them are like hidden partitions, where you can talk about, partitioning, right? So let's say you as a user, maybe you define the wrong partition key, right? And, if you run it on, Apache, Hudi, whatever, it's going to crash. It's going to look for that specific partition column. But in Iceberg, it actually creates these hidden partitions, which knows which is the right partition to be used for that particular query at runtime. So it dynamically figures out what is the right partition methodology for you. So you as a user don't have to worry too much about it. So that's why we're trying to achieve this, by making it easy for you and ensuring that you also get the right data, right? And then we also have other aspects that Monica is going to talk about in terms of time travel and rolling back versions of your as well. Monica, if you can scroll down, yes. And there's more to be launched, right? We're working on a ton of features in conjunction with AWS and the Trino community at Starburst to come up with more suggestions, right? In fact, I remember 4.5 years ago, this might pop up in your mind, hey, what is AWS doing? We've had, competition, so and say, double quotes, right? But today, engineers on our side and Starburst, we're working together with the Trino community and developing features together for our customers, right? And so we have services like Athena, which also built on, open source Trino. They rely on our expertise and your expertise as customers, because you're the guys who are going to try it out. You're the guys who are going to identify bugs, right? So I recommend you, to closely check out the GitHub repos that we're going to share after this. We have a huge open source community on the Trino side that we're working very closely with, and there's a ton of artifacts that we can share with you guys to take back and learn more about what are the key differentiators and what are the features that Apache Iceberg offers in detail. Next slide, please, Monica. And it's also important to understand the use cases, right? I think it really depends on what you guys are trying to build your data lake for or Icehouse for. Number one, you could be a retail, company, and you want to just figure out, is my inventory in stock or not, right? So you have an API call, making an API call, you're checking if it's an inventory, you're dumping the data set there, and then you're saying, hey, today's date and yesterday's supply, what is the delta, right? What is available in stock at this point in time? So the reason I'm giving that example is we've moved from just batch heuristics and heuristical analysis to real-time addressable issues, right? And that's where we've gone today. The other one we talked about is fraud detection, right? Like I said, Monica is going to cover that in a bit as well. And think of every industry. Think of the airline industry. Maybe Boeing is not the right example. I know Delta had a few glitches this morning. I guess an airline almost crashed. I have a flight back to Seattle in Delta, so I've got to think twice about my flight back. But the point is, if Delta wants to find out what are the spare parts that this particular airline model needs before the next flight, or are there predictive maintenance that we need to do on this airline based on the number of hours it's been in air, based on the travel time, based on the routes, all these things are data points that you need to feed into your system. We can do all of those, right? So there's a ton of use cases. And I see there's a question on Apache Iceberg compared to Apache Hive. It really comes down to Musab, the use cases, right? And yes, you are right. Eventually, the point is to replace it. We are seeing a lot of customers migrate from Apache Hive to Apache Iceberg for well-known advantages that Iceberg has. And Musab, we can actually talk, one-on-one, and we can talk about your use case, and we can see what is the best fit for your approach, right? We're not saying always pick Apache Iceberg, always pick Apache Hudi. It really boils down to what you're trying to do, right? So maybe one of the two might work best for you. But we're seeing customers eventually migrate from Apache Hudi to Iceberg for the reasons I just talked about, right? Monica, we can go to the next one.
Let me just add one point there. I think a lot of what we're seeing for the Hive to Iceberg is essentially people are migrating when they want to use that multi-engine, when they want to build with that optionality, when they're looking to upgrade from just that one sole engine or that one place. They're looking to really decrease their vendor lock-in, all of that. That's one of Iceberg's biggest benefits is the multi-engine support, right? We're seeing all the people on the slide are looking and supporting that. So that's something to really consider. The interoperability is a big factor there.
Yeah, no, hey, that's a good call out, Pavan, by the way. So I think what we're trying to explain there is, that feature did not exist before. It was pretty recent, right? When we're talking about real-time streaming and CDC ingestion. So that was something that was pretty recent that was popped up, right? Based on customer demand. So that's why we've highlighted that one. Okay, perfect. Now, this is what Monica is going to dive into it really quickly now, but I just want to tell you that this is not, the architecture that everyone should be using, right? But this is a basic architecture. just to define the use case, right? Work backwards with your customer, figure out what you exactly want to do. And I always recommend customers, you know what? The simple or the more less complex your architecture is, the better design you have. I'm not saying every use case has a very simple architecture, but it really boils down to the basics, right? Where are you storing your data? What compute engine are you using? How are you cataloging the metadata, right? How are you using the landing and transformation zone, right? And then based on your use case, what compute engine you're going to use, right? So that's where, and Monica is actually going to walk you through this through our hands-on lab experience. Next one, please. This is slightly more complex based on the use case, right? So in this one, we're introducing the real-time streaming, the CDC approach, right? Where we actually have, Amazon managed Apache Kafka, which helps in streaming data. You have a combination of batch and streaming data sets. Maybe, you use a combination of Glue ETL, Kinesis Data Analytics and EMR to do some kind of analytics, right? Based on what you want to look at. Obviously, Kinesis Data Analytics is great for spot analysis, right? Ad hoc spot analysis. Glue ETL is great to transform the data or massage the data, as I like to call it. And then eventually you catalog the data, store it in your Amazon S3, and then you use Starburst to query the data and eventually build out a data product, right? That you can surface to your end user. With that being said, I will hand it over to Monica.
Awesome. Okay, let me get situated here because this is going to be some screen share Jenga. Okay, so I've got my information here. And essentially, let's open the lab guide. So in your top right corner of Goldcast, go ahead and open the lab guide if you want to participate. But like I mentioned, all of this credential is going to be open until the end of Sunday now. Thank you, Pavan, for participating in the chat. You have made it so that everyone gets the credentials through Sunday. So let me go ahead and share my screen and we can go ahead and jump into it. So the intention of this lab is to really get you hands-on with the experience that we will have of, using Glue, using Iceberg, using AWS, using Trino all together. And again, we're doing that through Starburst Galaxy because we can all get up and running really easily. We can manage the lab credentials and we can essentially start running. So I have my lab here and I'm just going to get started on page 7. And by doing so, actually, excuse me, we're actually starting on page 10. What we're going to do is just kind of introduce our prompt, right? What are we even solving for? So our first thing is that we're going to look inside. We are actually going to be participating in something that close to home for me, as I used to be a data engineer in the fraud space. What we're going to be doing is looking at data engineering at Burst Bank Regional Bank. So what we're going to have here is we have a new potential fraudulent scheme that's come up, specifically risking transactions around the world, those account takeovers. We have people that are going to be taking over accounts in a place that we don't want, right? And so what we need to do is do some data discovery, transformation, clean up our data, and then we're going to create a data pipeline in our data lakehouse. Let me zoom in on the screen more. Great call out. Let's see. I can zoom. There we are. Hopefully that should help.
Yeah,
okay,
a lot
so
better, Monica.
okay, perfect. So now we can see, and you can see we have our quick site set up for after so that we can also visualize that data in our screen. We have the gist that is linked in the chat. That is going to have all of the different SQL statements that we're going to run. So in case you don't want to do copy paste, the gist will help you in all of your endeavors. We actually are going to be partitioning our data by day. We're pretending that we have 6 days of data that we need to really analyze in March to decide if this is, more than a trend or not. So we are going to look at these 6 days partitioned each by the day and then build out from there. This is Hive data that's being loaded for us, and then we need to transform it into Iceberg as well. So with that, let's go ahead and jump in. The first thing we're going to do is actually connect to our Amazon S3 Kafka catalog, right? So that way we have the connection to our data, and then we can build from there. And one important thing in this open data lakehouse architecture, I've talked about specifically the importance of optionality, of avoiding that vendor lock-in interoperability. One of the things that we can do with Starburst, or basically with Trino, essentially with Trino, is be able to combine that data from multiple different sources. So you don't just have to have your data live in the data lake. It can actually live in the data, it can live in a database. You can query it together, and then you can build going forward in your data lakehouse. So with that, I'm going to get started by connecting to the catalog that we need. And so I'm just going to hit that create catalog button. You can see we have different options with object storage, additional data sources. We have the additional data source already loaded for you. So all you have to do is do this one connection to the data catalog so that we can build from there. And one note, actually, before I get going, we are going to be all utilizing the same glue schema or glue database in AWS, but it's a schema on our side. We're all going to be using it. So please be cautious of the names of as you're naming. I've made sure that you name it very specifically so that we don't step on each other in our training environment. And this way we can actually kind of watch all the population as we go through the lab. And, we can see who is, building, and, you can evaluate all of the different tables. We can learn together is a fun way of saying it. We usually don't do this. So with that, I'm going to jump into the catalogs, and I'm going to create my connection. So I'm going to just follow the lab guide instructions on page 10, and I'm going to add the catalog name, which is just going to be our connection to the data lakehouse. And then I'm going to add the description. So we're looking for specifically web logon actions in this one area that we're looking at. And then we are going to do some analysis on that data and see if we need to involve the financial crimes team. So I've clicked on my connections. You can authenticate in two different ways. The first way, we're just going to use the AWS access key. And I'm going to copy the access key in the lab. And this is, I promise, the hardest part, getting set up, and then we can really go forward with all of our learnings. This is the hardest part. So we've got our access key set up, and now we have our Metastore configuration. As we mentioned, we are going to be using Glue in this instance. With Starburst, you can use either of any of the 3 different Metastore options that we have available. We're going to use Glue today. So we've got our Glue region. I'm going to select as US East Ohio. The bucket name that I want to select is going to be Starburst 101 Hands-On Lab. Again, that way we don't step on each other, and I can give you access to the data that I need. And then we also have the directory name. So I'm going to copy paste from that page 10, and you see it says data lakehouse / your name. I'm going to delete that and put my name. And I'm going to put Monica Miller Lab just because I know I've run this lab at least twice today. So I want to make sure that I'm starting from scratch. So with that, I also want to turn on allow creating external tables and writing, because we are going to be, cleaning and optimizing the data as we go along. And we, of course, are going to be using our default table format as Iceberg. Going to hit that test connection button, and we can now hit that connect to catalog button. So we've connected the catalog. We talk about, permissions, governance, all of that's really important. That's a topic for another day. I'm going to hit save access controls for now. And you can have the add to cluster portion. So the way Trino works is you connect to your catalogs and your data sources, and then we're capitalizing on the separation of storage and compute, right? So this is the cluster powering the workload, powering essentially the cluster that you need to run your data information. So I'm going to select actually this free cluster that we have available, and I'm going to hit add to cluster. So everyone should have that cluster availability. You can also see here that we have data discovery in Starburst Galaxy, which helps you automatically discover your data. You can also do this with Glue, which we have a link later to send out for all of the informations if you want to use the Glue crawler. And I'm going to hit do this later for now, and we can run. Now let me go ahead and show you our Glue database very quickly, and then we can look and see what's in there. Let me reshare so that you can see my entire window. Entire screen? Yep, why not? Let's share the entire screen. Okay, here we are. So you can see, oh no. You can see here that we only have one table in our database right now. And let me see if I can make it a little bit bigger. And let's zoom. But essentially all of those different options with, Glue is a really powerful tool. You have all of the getting started. You can do some of the visualization, visual ETL, the notebooks, the catalogs. We are looking at the database specifically. And in there, we have that one table for us, or you can see all the different tables that we have available. But looking in you can see we're big fans of Glue here, but looking in our web logon actions database, this is where we're connected. And we have already configured on the back end an IAM role that connects our S3 location with our Glue database. So there is a little bit of configuration on the back end. That's why we are, when you're setting Glue up for the first time by yourself to connect to S3, you can set it up the way that you want. It's very configurable. We are doing this lab environment here where you're using it our way. So that's why we have the credentials only open till Sunday. But we have this little test data table in here. We have nothing else yet because we haven't made any tables, which makes sense. So we'll be able to build as we go forward and kind of reference back to this database and tables and see what pops up as we go through. So I'm just gonna move that back over for now. And if I go back to my lab guide, we are on page 13 of the lab guide. So what we're going to do really quick is pop over to the query editor, finish that setup, and then we can absolutely get started with running all of our queries. In the gist that I set up, as I mentioned, we're going to have specifically using that same Glue environment for everyone. We are going to have table identifiers for our entire lab, right? So you're going to have your first name, your last name, and your zip code. And then we're going to have the ending suffix of, bronze, silver, or gold based off of the medallion architecture. Because one component of the data lakehouse is that, you have all of this different data that has all of this different type of cleanliness, data optimizations, all of that. So what do you need to do is you can use the medallion architecture to separate out this data based off of like the level of cleanliness and security or just you have around it, right? So we're going to start with our LAN layer or our bronze layer, which is just the raw data we're pulling in from S3. We're persisting it today. You don't have to persist it. You can grab it from the crawlers, grab it from data discovery, but we're just persisting it today to get the point across. And then you can build on your silver and gold layers as well. So the silver layer will be that clean and optimized data that's converting from Hive to Iceberg here. And again, the goal to do that conversion is because we have the ability to actually utilize that multiple different engines and tables together, right? And then we're going to have that gold table, which is our table that is curated and trusted and ready to be sent out into the wild. And we will secure that with the proper governance here. So with that, let us jump in. So I've already copied and pasted. I cheated a little bit before you. I plugged in my first name, last name, zip code, and then I have all of my identifiers here. So I'm just going to do Control F, and I'm going to find everything that has Monica Miller 75024. Actually, I'm going to copy this part over. And I am going to replace it with Monica Miller 75024. And that way we should be ready to go with all of my queries. And I'm also taking out all of the different, you can see we have 27 instances highlighted. So I am going to replace that here. And hopefully that worked. That is the first time I've tried that. If not, I have the queries available so we can look at it. Okay, we can see one didn't work, but we'll copy paste going forward. Okay, so with that, let's jump into the lab here. So we can see
Monica?
that we are, yes.
There's one question in the chat if you can see that.
Yes, I would love to jump in there, Pavan. I will explain it when we get there. You're ahead of me. But I'll be happy to jump in there. Yep. Okay, so validate the connection. So we're just gonna make sure that up here you're configured properly. You wanna have your free cluster. I am going to actually turn my cluster on, make sure it's ready to go. And then we want to look at the catalog that we want to connect to, which is the Data Lakehouse catalog. And then, of course, we have the schema that we're connecting, which is our web logon actions, which is actually our database in Glue. The way that Trino works, we have that one-to-one. It's not necessarily the one-to-one mapping. So the schema in specifically Starburst will map to the database in Glue. So we've got that information all configured, so we're ready to go. And I think we're about to answer, hopefully, your question, Pavan. Go ahead and try that replace here so that all of your queries are a little bit easier to run. We're going to move pretty fast through the lab 3 portion, which is, configuring, building your data lake. I'm just going to pop over there and give a little bit of an explanation for the recording in case anyone is watching this live or watches this as a record and they want to know about it. So on page 15, what I'm doing is navigating to the cluster editor, and I'm just going to edit here, and you can see I have all of my catalogs selected. I have my Data Lakehouse catalog, which we created, and then I have my sample catalog, which is what we're going to actually use to showcase that federation. So in this example in the lab guide, it's a Postgres database, but you could use it as a Redshift, you could use it as anything. It's basically, it's a sample, right? But you could envision it as any sort of database you have, or NoSQL database or stream, anything that you need to connect that data from multiple different sources, expanding past the data lakehouse, right? So we've got our catalogs. You have different execution modes you can select. Standard, fault tolerant, accelerated. This is just helping to accelerate Trino in the best way possible. And then you can basically get your cluster size as the example that you need. So with that, I'm going to hit the cancel button and I'm going to get started. Okay, Pavan, I see you've got I see you have a access denied. I will go ahead and jump in, and then we can try our best to get that fixed. So I am going to go to page 18 of the lab guide, and we are going to look at the bronze layer. So I've got the query editor available here. And the first thing I'm going to do is just validate that I have a working schema, that everything is set up as prepared. So I have my free cluster, my data lakehouse, web logon actions. So I'm just going to select from test. I'm going to try that and then see if everything is working as expected. As we select, we should get a response back. We'll actually get my dog's name back. As I was testing, it's like, well, let's put Phoebe in there as the database. So as one of the records in our table, so we've got we can select properly, which means that we're connecting to Glue. We're able to read, and so we should be able to build out going forward. Now what I'm going to do is look at step 2, creating the bronze level table. So we can see that we are pulling create table from our data lakehouse with web logon actions. And I've got my name here with bronze. I've got all of the different specific columns that I want. And then I have it as a hive with a type JSON looking at that external location. Oh, Pen, that was probably because my cluster was down. So that's not normal. It's because it was starting up. So don't worry. It was just me. I forgot to restart it while we were talking during the lab. So let's go ahead and run this table. Moment of truth for Pavan. See if we get access denied or if we get running complete. So with that, Pavan, the role account is not allowed for Starburst 101 hands-on NYC Uber Rides actions. I'm a little confused on where you're getting that issue, but I'm happy to dive in with you after. If you want to set up some time with me, we can get that figured out. But considering you were at the partition metadata stage, I think it might be a little bit lower. But we'll look into it. So I've created my first table, right? So if I actually refresh here in the free cluster, I will be able to see the web logon actions, and I'll be able to see this new table that I've created. And this table is the connection for specifically the bronze. If I open it up, you can see that bronze level. And the next thing I'm going to do is actually call the system sync partition metadata. So you ask, what is the purpose of this? This is specifically because we're utilizing a metastore and we're using Hive. So we need to sync the partition metadata that is in the table. We've created that table on the S3 side, but we need to connect it to Glue. We need to basically bring that connection together so that you don't have any issues. So in here, you can see the first part of this command is to call specifically the schema or the database in Glue. Then we're going to call that table. And then you can either do add, delete. It's adding that partition since this is our first add of running that table and creating it as a Hive table. And again, this is a problem you have when you persist. If you didn't persist, you wouldn't have that issue. So I'm running that, and then we get that response back. Hopefully that went faster for you, Pang. We can see this was 0.75 seconds. And so now if we open up that data, we should be able to see all of the information here. Let me run a basic select. Let's do an experiment to validate that the bronze table works as expected and that you are able to get rows. So here we are, we can see those rows that we return. We have the information for us. And then now what I'm going to do is go to that silver layer. This is where we can get actually into some of the Iceberg exampling and look at the time travel, look at the schema choice, look at all of the different things you can do with Iceberg, that modern table format giving you the power to apply those data warehouse-like capabilities to the data lake. So I am going to continue on page 19 to build my silver layer. This is going to be where we not just update the Hive table, we're going to also change the format to Parquet. And really what's important here is we're going to create the table as Monica Miller Silver from that specific bronze table. Okay, so what I'm going to do is run that command. I am going to hit that run button and I will be able to get the response back from my table. And I am going to select from that table to showcase the information that we have here. So Pavan, to dive a little bit deeper, you notice in that earlier example, we had to do this sync partition metadata because we were using Hive. And the reason we're using Hive is because that's what was available in our ingested data, right? It wasn't our choice. That's what they gave us. And so we needed to add that Hive partition to our metastore so that we could read the table information. We don't have that problem anymore going forward. And if you are able to, take some time and work on some tech debt and build out all of, maybe update some of those jobs that are coming into S3 in a different way, you won't have that issue at all because we can just run the specific silver table. If you potentially miss that, we don't have to do that add sync partition metadata each time. So I clicked on, row 46 where I'm selecting from the silver table. And this, if you're like me, you're like, why are you doing that? That looks exactly the same as what you had in the bronze layer. Well, it's really important to look underneath, right? So upon first glance, the data looks the exact same, but we know it's so much more than that, right? If we look at this create table statement, we can see instead of using that Hive table format or using specifically the bronze, using JSON format, we've updated it to Parquet and Iceberg, which are kind of becoming industry standards at the place that we're at with data. Parquet is certainly one, at least over Orc, and we know that Iceberg, whether that be Iceberg or Ice Delta or whatever you want to call it, they're making strides to be, kind of the winner after the summer's event. So you can see here that the underlying information of the table has changed, while the data that we present through the query engine may not have changed very much for us. So now we're going to start with some of the awesome parts that you can do with Iceberg data manipulation, because those are really important. And we are going to actually look at page 22 of the lab guide. So before we do that, I want to talk a little bit about what we keep talking about, those data warehouse-like principles, applying that to the data lake, right? So things like update, delete, merge, like we mentioned, we weren't able to do so previously, but now we can actually add that functionality into specifically the data lake and building that data lakehouse. And that gives you, like we talked about, the price performance. It also gives you the ability to, continue on scaling as cost, real time, unstructured, structured, semi-structured, all those data types grow. So with that, we are building from scratch here today. This is an example as using that fraud detection, right? So we're going to show some of the things that you can do to manipulate your data utilizing Iceberg. The first thing is schema evolution. So with schema evolution, you can actually alter the schema based off of new snapshot setup here, alter the table. This one's pretty similar if you think about it, like to what a database would be. And also, if I refresh my schema here, we'll see my new data come in. I'm going to hit that alter table button to do that Iceberg manipulation, and we're just going to rename the column to make sure it's the right case. So I'm going to open this up here. If we look before in the silver table, we'll see that cust key does not match the rest of the other types. So we're just going to do a quick alter table to update that column, rename it properly. And then if we hit that select statement, we'll be able to see the partitions available to us in that table because we're using that Iceberg table format. So I'm hitting that run button, and you can see here we have partitions still by that date like we talked about. From the beginning, you can see the record count, you can see the file count, and you can see all of the data min and maxes inside as well. And so now we're going to look at the snapshots. So the snapshots are a really, really powerful tool. You can look at these manifest metadata tables to look at, it's basically a record of all of the different changes you've made to your table. So if I hit that run button, we'll get the information here where you can see this was the table creation, right? We can see the information from that specific data addition. And now we can go forward and let's try a delete here and see what happens to our snapshots. So if we look at specifically the DML statements, we're looking at the table, we want to do a delete because the financial crimes team has told us that anyone who logs in twice or once, we don't think is a problem. So go ahead and run that delete statement from where you're at. So I am running delete specifically from my Monica Miller silver table. So this is because I'm doing some of the manipulation in that cleaned and optimized layer using Iceberg and getting the information that I need. So I'm going to hit run, and I'm going to delete where, someone got in less than 2 attempts. We don't need that information. And you'll see that we deleted approximately 4,000 rows. And if we select from the snapshots again, we'll get that second snapshot that's now been added to essentially change the information. So you can see that we have a delete operation where we deleted from the table. So if we click on that summary, you can see where these positions deletes were, what changed, the total files, all of the information you may need. It's a record of our change to the table, right? It's a metadata record of the changes that we've had. So very important going forward in case you needed to potentially roll back those changes, you needed that data. This is something that you would have the option to do. So now I'm going to hit on another, principle where, not only do we have the snapshot IDs, I forgot to mention the parent ID here. You can see it's connected. So we have this second snapshot ID is showcasing, you see this parent ID, and it connects here with the actual snapshot ID that we used. When you're using Iceberg, I'm sure some of you may know, as you mentioned, you're a little bit more advanced, that this can get a little crazy when you have a lot of different snapshot IDs in play and you are doing changes that may conflict with each other. So it's just important having that lineage of all of the metadata information through the snapshot IDs and the parent IDs can really help you out as you're looking forward, branching, tagging, all those things in Iceberg that provide a lot of benefits. So now we're going to do another update to the table, and we're going to actually change. They've told us that instead of looking at the IP address as null, they want to look at it as -1. We have no idea why, but that's what they said. So we're going to do the cleaning and optimization to do that. And I'm going to create that run table, specifically looking at my silver table. Again, I'm going to hit that run button. So we've updated 1,000 rows, and if we select where it's null, let's see if we get anything response. We should get nothing back, which we do. which is a good thing. And if we select from that snapshots table again, we will see that third snapshot, which actually has that overwrite, changing the 1,029 rows and making the change to specifically update from the null value to the -1 value, but as a varchar because of where the table is or the data type is. So if we select from a specific customer key, we're just going to look at it here and select from that specific customer key, we'll see that we have a customer range of a lot of different options. They have IP addresses that are that -1, that change that we just showed, as well as the customer key showcasing, different login attempts throughout those 6 days that we have in question. And we can see the different values. They were all false for this one person, which is strange if we look at it. But what we want to do here is utilize specifically our utilize time travel. So if we go to page 24 in the lab guide and 25 in the lab guide, what we're going to do is we've selected from that specific customer key. Now what I want you to do is go ahead and grab the snapshot for the second snapshot ID that you have. So I'm going to hit that run button again. And I am going to grab the second snapshot ID here. And I'm going to copy that over. And I am going to put that in my query right below, because that way I will be able to see, I can select from that table for that specific version of Iceberg. So I am going to click run and I'm going to select. So I've selected from the table here, and if we actually run that command, you'll see instead of showing that -1 that we saw previously for the most recent version of the table, we can actually look behind at the IP address in here. I see a question really quickly. The lab guide URL is actually in the docs tab, and it will be sent out after the lab as well. I also see a question about where are these catalog tables being stored. So they're actually being stored in AWS. We have connected to that Lakehouse. We're storing our tables in S3. That's some of the setup that we've done on the work for you as well. But if we go in here, I can just show you really briefly. And we hit that refresh button. Oh, let's click in here, Data Lakehouse. These tables are being stored in here. So you can see that web logon actions, and we can see all of the different tables that are being stored. So they're being stored in S3. Okay, let me go back to my lab guide. And then okay, I see your comment, Pavan, and I'm so sorry that this is not working for you live. Let's get on a call and debug it, because you should be able to. I've tested with multiple different accounts of my own, so just to make sure, you should have access to the web logon actions based off of the specific checks and balances that we've put in place. So yes, you will be able to have access, because whether you and I debug it today or anything that we do, we'll fix it absolutely. So one thing I want to call out is a lot of the catalog configuration is really important. So if you could run that test query at the beginning, you should be good to go forward. But if we look at, let me scroll over here. If we look at these login attempts and we can edit that configuration, this is the bread and the butter. So this is actually you should be able to put anything here after this and be able to connect as well. So with that, okay, you ran the test query, perfect. So we'll debug later. Apologies for all of that. Okay, so I'm gonna back up a couple of steps, because I have one other question that's in the chat, and then we'll run forward with time travel. The data that was copied, yes, it was copied into the bronze table. We did persist it this time. That was to be dramatic and show you the different changes between the underlying layers of the Hive and the Iceberg table. You can also do where you don't necessarily need to create that new table. You can either use a materialized view that just points upstream, or you can do other options where you just run that ad hoc query. You don't necessarily need to create that whole other table. We did that purposefully here to execute that medallion architecture and build going out forward. Okay, so and CJ's got a perfect answer. So thank you so much, CJ. I really appreciate your help in the chat. Okay, so with that, I'm going to select. Let's start over here where I've shown you the different snapshots I have. And I want to roll back, right? We saw that options where we had the two different types of, we updated the table. We could either look at the IP address as -1 or the IP address is null. And if we select right now from the table, we'll have no null values because we did that rollback, right? Or because we did that update. Our goal is to now roll back that data so that we can actually realize, oh no, they decided they don't want that information. So I am going to copy over that snapshot information so that I can put it in my query. As I showed you, we put it in that query, copy the snapshot, put it back in that query, and then we'll get the information that we need. You can see we have that IP address is actually updated to null, whether if we queried it right now, it would say -1 based off of the latest metadata extraction that we have. So what I'm going to do is actually do a rollback using this version identification, that snapshot ID. I'm going to place this in my call data lakehouse command, and I'm going to hit that run button. So I'm able to actually roll back. And now if I do that same select query and I hit run, we'll see that we actually have the null values as opposed to the -1 that we updated it from, which is, just kind of showing you how much easier it is to manage your metadata on the data lakehouse with Iceberg as opposed to stuff that we find normal in the data warehousing space. So I'm going to also go on to page 26, and we are going to talk about table maintenance. We've talked about when you're doing all this thing, there is a little bit of a, not cost, but there's a consideration you need your performance updated as well. And so with that, with your performance degradation, you need to be careful of the files that build up as you're doing operations on your tables. So one of the things about the manual table data is that, or the manual table maintenance, is that we want to kind of get rid of some of those snapshots that we don't necessarily need anymore. So I'm going to clean up the table maintenance starting by the execute optimize command. But first I'm going to show you the amount of files that we have using our metadata table, and then we'll make those smaller. So I'm going to hit that run button, make this big again. And we can actually see that we have the alter table execute optimize command, but look at these files that we have. We have a lot of files from me building up and doing all the commands that I've done. And so we need to make these smaller, right? So anything over the threshold, we are going to hit alter table and we're going to run. So I'm going to hit that run button. And then if we select again, we will see a lot smaller of files. We've grouped them together. Sorry, not smaller files. We will see the smaller amount of files because we've grouped together the amount of records, and we are, cleaning up after ourselves as we iterate on all of the table maintenance. So the other two commands I'm going to run are just kind of to show you about what you can do with, what you need to do. We need to expire our snapshots beyond a certain threshold. A lot of people use 7 days, and also remove those orphan files that may be looking on behind that 7-day mark. One thing I want to show you really briefly, this is not in the lab guide, but I'm just going to duplicate my instance really quick. I want to show you that you can actually go into your data catalog and you can do automatic table maintenance, because sometimes it's hard to create those ETL jobs just to run table maintenance on the tables that exist in the catalog. So you can actually go to the access control, go to the jobs tab. If we go to the quality tab, you can create a job that will do compaction, it will do data retention, it will do vacuuming, all of the work you may need to do. You can actually schedule that. And let's say we wanted it to repeat daily at 12 a.m. You can hit save and you can have that information for you. Okay, so with that, I'm going to go back to the query editor and we are going to create our final select statement for our gold layer. With that, we can just select. I'm going to do a join. This is the portion of going beyond the data lake house. So you don't necessarily have to look with just the data that lives in your data lake. You can actually look at joining data that lives in different portions of your data as well. So like the Postgres data or other different areas as well. Okay, so I've got that information. You can see we have the different specific connector here. We've got connected our data from one different query. We've got two different data sources, which is really powerful. And if we just go ahead and run, what we're doing is that same command that we did the select statement on, we're actually going to do the create table statement. So I'm going to just look specifically for that data that we're joining from, some customer information we have living in our Postgres database with the data that we have living in our data lake from the logon actions. We're joining that data together, and we're identifying the data in the, that has login for 5 times past the amount of dates, so it's like they've tried logging in 5 times over those at least 3 different times, right? So we're just looking for that accumulation of potential fraudulent activity so that we can send that to our financial crimes team. So I'm going to hit that run button, and we should get back the information here where we can see that if we just select from that table, we'll get that fully data joined together, as opposed to having to just continue running that select query. So you could essentially, what you could do is just create that one ad hoc query, and then you could persist it as a materialized view. So it could just come up every day as new data arises. You could only have that information, and then you could build from there. As far as I see a question in the chat about automation feature only available in Starburst Galaxy. Right now, it's only available in Starburst Galaxy, but there's actually a lot of work that we're doing to bring Icehouse to Starburst Enterprise. So I'll find that information for you, and I'll email you as to what the expected dates are for that or where it is on the roadmap. So that's kind of the different medallion architecture that we see in our web logon actions. So we've got our different tables that we've built, all of the information there. And now what we want to do is just kind of run through. You can secure your data products as well now. So if we go to the admin, you can actually click on the access control. You can click on the tags. You can create a tag. So if we hit that create tag button, we can look at PII, and we can just put the tag of choice. And then if we wanted to create a new tag that was specifically nested under it, so Galaxy has the RBAC and ABAC different tagging architecture. So it's actually a double hierarchy so that you can tag basically anything that you could imagine. I'm going to add the phone number tag and put it under the PII tag. And that way I have the information for adding any of the data. So if I go back to my data catalog, in this information in the data catalog, we can see a lot of good things in here. In the web logon actions, we can look at the tables that were created. We can look at, if we click on this gold table, we can actually look at the quality. We can look at the lineage of the table. So you can see all of the different final table being developed from all of our iterations in the medallion architecture. And then we can also see, any of the SQL queries that we have to actually create those transformations. Okay, so we've got our information there. Now what I'm going to do is just assign my, phone with the tag that I just made, specifically the phone number tag. We know it's PII, so that if I want to do any masking or row eliminating, I can do that via this tag that I've created. Specifically, I would say like masking the phone number, masking the last name, any of that information. I also wanted to just briefly show, I know we're coming up close on time, so I wanted to just briefly show on the specific, access control that you can do. If we click on the access control information, you can just hit the add privilege for specifically that gold table, and we can add it to either one of our existing roles, or we can create a new role, which I'm going to skip for now because I don't think we have the time to do so, but I'm going to add it to my data engineering role that I want to only be able to select from that table. So now if I actually go to that data engineering role and I run the information, I will be able to select from that table. And then, I may or may not have the permission to actually update. If we run the delete command available on page 35, we're going to try that and see if we're able to do so. we can see we get that access denied, and that's because we did not give permission to the data engineering role to actually be able to delete. So this is a little bit of an information dump in the sense that we talked a little bit about that governance component. You need that throughout all of your different, iterations of your data architecture. So just wanted to kind of give you a brief showing on that as we go and look at QuickSight. So the last part of this is actually visualizing your data with QuickSight. So what we want to do, after we've discovered, cleaned, optimized our data, the last step is actually to visualize it. So if we go into QuickSight, and this is a demo portion only, but you can set up all of this using the lab guide. I put all of the steps that I had for myself there. So it's really easy to connect if you just need to do it in your own AWS environment. But we can actually just go to our data sets and we can connect to a new data set. I'm going to choose the Starburst connection. And I am using Starburst Galaxy for this example, again, because that's our training environment. And I'm going to make the data source name web logon actions. And then I just put in the database server information, which I can find specifically in the Partner Connect availability that we have. If we click on Partner Connect, let me go back to the account admin role, and we search for QuickSight, we'll be able to see the information. Make sure you choose the cluster of your choice. And I've got my cluster information, and I can actually connect there, and I can select the catalog that I need, which is the Data Lakehouse catalog. And then I've got my username, which is available to me in Partner Connect, and my password, which I've copied on a notepad because I forgot it. And I can hit that create data source. Uh-oh, this is what I get for doing this live. Database server. Oh, I used the wrong username. Sorry about that. Let me copy over here. And we are able to connect to our data source. So we are just going to, for now, collect on the web logon actions, and I'm going to select that gold table that we have, and I'm going to just click directly query for today. And in this, we can see there, I've played with QuickSight not very often, and I'm not a super visualization girl, and it was really easy for me to get analytics in 15 minutes, very, very simply. So one of the ways that we're going to explore is just by looking at the count of login attempts by login date. So, we have all of our information, our fields here. If we go to an area chart and we just look at the information, I want to change that to just the area line chart. I want to look at the login date, and I want to look at specifically some login attempts and the count. I'm going to actually do the count because the sum doesn't make sense in this example. And then I can see all of the different types of login actions that have happened over these last 6 days very easily. And I'm going to add those data labels so that people know how many login attempts were happening for the specific, web logon usage. And then if I make a new sheet, I can actually look at the analysis a little bit deeper of those login attempts, and I can compare them to the successes. So I'm going to actually look at the, the login attempts of the area line chart. So I'm going to bring that over, and I am going to select the login date. I'm going to select the login attempts. Going to put that as a count. So very similar to what we just saw before, we'll see the same data coming out. But now if I wanted to add maybe that login success count, we can see that difference together and see kind of the percentage. Oh, apologies, I used the wrong. This is a sum, sorry, because it's a true or false statement. So we can see here that we have the login success to attempt ratio. I'm sure we could look at the legend and add some more information there as well. And then just for fun, there's also an interesting component looking at the specific risk of the customers that we have. We did that join. So we have the data looking at their risk profile. So let's look a little bit about what their risk appetite looks like. So if we click on the sand key diagram. I've seen these a lot online recently, and I'm going to select that customer segment and then the risk appetite. I'll be able to look at the information of like, okay, these are the different types of levels of our customers. What is their spending habit risk look like? So very interesting to see that, a lot of people that maybe aren't as high are more risky versus those who are a little bit higher in their profile are more conservative. So with that, I know there's a lot of information shared in a very short amount of time. What I'm going to do is stop sharing and say thank you so much for joining us. And if there's any questions that you may have right off the fly, go ahead and let us know. We will do our best to answer. And if not, we'll send you an email with an answer. I've taken a lot of notes today from other question marks that people have sent, and we'll be able to get you those answers followed up for sure. So thank you for joining us.
Thank you, Monica, so much. I really appreciate it. I know it was a lot of work, put into those labs, and the demagogues will not win. Not today. Yeah. Thank you so much for everyone for joining us. And I think, as you could understood the entire workflow, end to end from the source to finally visualizing it. Feel free to try it out and send your questions our way. Happy to address them. Thank you so much.
Awesome. Thank you.
Cheers, guys.